Yes children, now we discuss the concepts of refraction of light at a plane surfaces. Here the first important point, before going to what a recall one's refraction, here we need to learn about the two important words. Let us say two important mediums, okay na? Rarer medium and denser medium. See, this optically rarer and optically denser we can understand in terms of speed of light. The medium in which speed of light is more than that of other medium is called rarer medium. Whereas the medium in which speed of light is less when compared with the other medium is called denser medium. Children, we know that very well, no other object can travel faster than the light, and the light can travel fastest in a air or vacuum only. So as long as the light is traveling in a particular only in a single medium, it will go in a straight line path only. But what happens when it enter into the other medium? Definitely there will be change in speed, due to which what will happen? It will deviate from its path, it will bend. This phenomenon only we can call the refraction of light. So how can we define, children? When light travels from one transparent medium to another transparent medium, what happens? It bends at the interface between the two mediums. This phenomenon of light is called refraction. Is it clear? Yes, it's a very important. And here, what happens when light travels from denser to rarer medium? It moves away from the normal. When light travels from rarer medium to denser medium, it slows down, so it moves towards the normal. And during a refraction, children, frequency remains constant, and whereas speed, wavelength, even intensity will change. Okay, this is very important. Now comes to the laws of refraction. Laws of refraction, children, according to the laws of refraction, incident ray, refracted ray, normal drawn, all will be lying the same plane at a point of incidence. And the second one is that the ratio of sine of angle of incidence to the sine of angle of refraction always remains constant. It is called Snell's law. But here condition is there. It is applicable for a given pair of two media. The moment when medium will change, again that will change. So means we have to keep two mediums a constant. Okay. This constant only we can call the refractive index. What is the refractive index, children? It is a ratio of speed of the light in a vacuum or air to the speed of the light in a medium. Children, refractive index of the medium can never be less than 1. It is always greater than 1. Why? Because C can never be less than V. Okay, fine. Refractive index, children, depends on the following factors. It depends on the nature of the medium, depends on the temperature. How? Inversely proportional to the temperature. And third one, color or wavelength. How it depends? Inversely proportional to wavelength. Which means what? For a red color, wavelength is more than violet color. Hence, the refractive index for a given medium is less for red color, more for violet color. Now we see the refraction through the rectangular glass slab, children. Look, here is a rectangular glass slab. Children, here if you can see, this side air is there, here is a glass, again here is air, which means what? Rarer, denser, rarer. When light moves from air to glass, it bends towards the normal. Again glass to air, it will move away from the normal. The angle between normal and incident ray is called angle of incidence. The angle between normal and emergent ray is called angle of emergence. Here what the important thing is that angle of incidence is always equal to the angle of emergence. Hence, angle of deviation is 0. So, glass slab does not produce any deviation. Rather, it only can shift the light ray. And here one important thing which we have to notice, children. So, there will be some perpendicular distance between emergent ray to the incident ray when extended forward. This perpendicular distance only we can call it a lateral displacement. Lateral displacement. This lateral displacement depends on angle of incidence, thickness of the glass slab, material or refractiveness of the glass slab, and inversely proportional to the wavelength. Which means what? For a red color, wavelength is more. So lateral displacement is the least. That is how we have to understand. Now, children, refraction through a glass slab. So here, look at here, A, B, C is a what we can do is a glass prism, children. Now here, let us say here is the incident ray. At this point, it is incidenting. Let us say this is the point P, it is incidenting. Here it is entering from air to glass. So definitely it will move towards the normal. This is the angle of incidence, here is the angle of refraction. So inside this is a refracted ray. Refracted ray. At this point, it is going glass to air, denser to rarer. So it moves away from the normal. This is called emergent ray. The angle between normal and emergent ray is called angle of emergence. Now this emergent ray, when you extend backward, children, it meets at some point on this vertical path of the light ray such that it makes some angle. This is called angle of deviation. Very, very important. Is it clear? Angle of deviation. Now check in examination point of view, they might ask the relation between angle of the prism R1 R2. What is the angle of the prism, children? The angle between two refracting surface of the prism is called angle of the prism. So here A is equal to R1 plus R2 and angle of incidence plus angle of emergence is equal to angle of the prism plus angle of deviation. But in the minimum deviation condition, children, this refracted ray is exactly parallel to the base of the prism. In that condition, R1 is equal to R2, I is equal to E. If you can substitute this, you will get R is equal to A by 2, I is equal to A plus delta M by 2. And we know that just apply the Snell's law at the first refracting surface of the prism. We know that mu is equal to sin I by sin R. So I value we got here this one, R value we got this here, A by 2. Substitute in the Snell's law, mu is equal to sin I by sin, mu is equal to sin I by sin R. In the place of I, we are substituting this value, hence we got this. So in this formula we use to calculate the refractance of given prism, means in a lab, experimentally we can calculate. Okay, fine. Now come to the angle of deviation, children. So examination point of view, definitions are very important. What is angle of deviation? Actually if there was no prism, children, it had to go like this. But because the prism it is going in this direction, means deviating with some angle. So the angle through which incident ray gets deviated from its original path is called angle of deviation. Angle of deviation. This angle of deviation depends on, children, angle of the prism, refractive index of the prism, that is the material of the prism, inversely proportional to the wavelength of the light used. But children, if you can see, there is some special relation between angle of deviation and angle of incidence. So you cannot say proportional or inversely proportional. And this graph also very important for examination point of view. Look at it, children. As angle of incidence increases, initially angle of deviation is decreasing, takes a minimum value, and further increasing the angle of incidence, the angle of deviation is increasing. Is it clear? Fine, children. Just make a note of it. Now next we see the total internal reflection condition, critical angle and total reflecting prisms. Just make a note of it. This will go in this direction. Fine, children. Now children, let us see first what is shift, children. So children, we might have noticed that what happens when a coin is placed in the tub in which water is taken, what happens, the coin appears as if it is shifted, right? Yes, children. So that concept only now we'll be seeing here. So for suppose here is a water, here object is placed, the depth at which actually it is placed is the real depth, but due to the refraction it appears as if it shifted upward, it means the image appears here. So the distance between from the surface to the image is called apparent depth. So this is not true actually, just due to the refraction it appears like that. Then what is shift, children? The height through which it is appears as if it is lifted upward direction is actually shift. So here also in terms of real depth, in terms of apparent depth, refractive index can be defined. How to define? Refractive index is a ratio of real depth to the apparent depth. And children, here how to calculate the shift? Real depth minus apparent depth, if you can do, then you will get the shift. So shift also can be expressed in terms of real depth and mu. And here one important thing, children. So for one more question, they may ask you to find the shift in the case of glass and in the case of water. So directly you can use, in the case of glass, shift is equal to Rd by 3. In the case of water, shift is equal to Rd by 4. How we got here? Just here you substitute the refractive index of glass, you will get this. Here you find the refractive index of water, you will get this. Okay, fine. So shift depends on here refractive index of the medium. More the refractive index, more the shift. It also depends on thickness of the medium. More is the thickness, more the shift. It is inversely proportional to wavelength. More is the wavelength, shift is less. So which means what? Which color will what a shift will show more shift? Violet color will show more shift. Done? Fine. Now come to the critical angle. Very important. Children, see, whenever light incidents normal to the interface between the two mediums, it will go undeviated. That is a no refraction case. And you look at here. So a light ray is moving from denser to rarer medium such a way that what is happening, so it is incidenting with certain angle such a way that the light ray grazes the interface, hence angle of refraction will be 90 degrees. That particular angle of incidence we can call the critical angle. I repeat once again, the angle of incidence in a denser medium for which angle of refraction in a rarer medium is 90 degrees is called critical angle. And this critical angle also related to the refractive index. How? Mu is equal to 1 by sin c. This is a very important. In exam they might ask you to write the relation. And the critical angle depends on two factors. It depends on wavelength. Okay, it also depends on the temperature. So for a red color, critical angle will be more. For a violet color, critical angle will be less. Now comes the total internal reflection. Children, to occur total internal reflection, light ray should fulfill two conditions. What are the two conditions here? Light must travel from denser to rarer medium. Light must travel from denser to rarer medium, and angle of incidence must be greater than the critical angle. So in exam they might ask this diagram or this diagram. Children, look at here. Let us say this light ray A. This light ray A, as it is incident normal, it will go undeviated. Whereas light ray B, children, it is incident with the critical angle, so it's grazes surface. Now if you can see light ray D, because see already we use for critical angle, right? I am not using that. So it is incident with the, see, it is going from denser to rarer, and definitely this angle is more than critical angle, right? So light ray is coming back to the same medium only. This phenomenon only we can call it the total internal reflection. Children, in exam they might ask a question. So what is the difference between total internal reflection and normal reflection? Children, during a normal reflection, some amount of light energy is absorbed. But whereas during a total internal reflection, 0% means no energy is absorbed. Whereas due to the normal reflection, whatever the image which you will get, it may not have that much brightness. But whereas due to the total internal reflection, whatever the image which you will get, it will be 100%, it will be having 100% brightness. Why? There is no loss of energy, right? Okay, now fine, children. Now, so let us see the occurrence of total internal reflection in a prisms, so called total reflecting prism. Total reflecting prism. Children, examination point of view, these are very important. So before going to understand this, one thing we should know that what is that the critical angle for glass air interface is 42 degrees. Very, very, very important. The critical angle for glass air interface is 42 degrees. Now let us take a total reflecting prism. These are the right angle isosceles prisms, which means what? One angle will be 90 degrees, other two are 45. For suppose if a light is incidenting normal to the AB, then it will go undeviated. But at this point, let us say P, children, what is happening? It is trying to go from glass to air, that is denser to rarer. And let us see, this is 90, it is 45, this will be 45. Obviously, this will be how much, children? 45 degrees, which means what? Angle of incidence is greater than critical angle. So here two conditions are fulfilled. Then what will happen? Light ray will undergo total internal reflection. So by default, it will become normal to AC, so that it will go undeviated. This case of the total reflective prism is used in a periscopes. Done. So this is actually here how much deviation? 45 plus 45. So here angle of deviation is 90 degrees. Now come to the here. Same thing, but this time light ray is incidenting normal to the BC. Try to understand BC. So that it will go undeviated. Let us say the point P. At this point P, light is trying to go from glass to air, that is denser to rarer. If you find here angle, this angle, here is 45. Obviously this angle of incidence will be 45 degrees, which means what? Angle of incidence is greater than critical angle. So it will undergo total internal reflection. By default, it will go to the parallel to the base of the prism, and same thing happens at a Q also. At a Q also, total internal reflection will take place. Finally, the light ray will go undeviate, means will emerge normal to the BC. Here 45, 90 plus 90. So total deviation is 180 degrees. So this case of the prism is used in binoculars and even cameras also we can use. Done, fine. Now let us see the total internal reflection in equilateral prism. Equilateral prism means what? All angles are equal. 60, 60, 60. Now children here, so look at this. Here the light is inciding normal to the AB, so it will go undeviated till this point. At this point, it is trying to go from glass to air, that is denser to rarer. First condition fulfilled. This is 90, 60, this is 30. Obviously, this angle of incidence is 60 degrees. Hence, it will undergo total internal reflection. By default, this light ray will be normal to BC, so it will go undeviated. Now, total internal reflection in 30 degrees, 90 degrees, 60 degrees angled prism. So here light ray is incidenting normal to AB, so it will go undeviated at this point, children. Here this is 90, 60, it is 30. Obviously this angle will be 60 degrees. 60 degrees is greater than the critical angle. So at this point P, light is going from denser to rarer and angle of incidence is greater than critical angle. Then obviously total reflection will take place. And here with the same 60 degrees will undergo here. At this point, if you will find the angle of incidence will be 30 degrees. So it's very important. At this point, light is going from glass to air, that is denser to rarer only. But angle of incidence is less than the critical angle. Hence, normal refraction, glass to air, it will go away from the normal. Clear? So these are the concepts of what we can say refraction of light at a plane surfaces. Okay, na? Just copy it.